Hello, my dear engineers. Today's discussion on protection coordination basics for substation design. Coordination of protective relays. The protection coordination is one of the most critical engineering tasks in substation design. What it ensures? It ensures only the faulted section is isolated by the protective device closest to the fault by minimizing the outages and protecting the expensive equipments in the active network of the power system. The rest of the system remains in service. This protection coordination plays vital role how the substation will be reliable and stable and as well as efficient also. So for that, the objectives for the protective coordinations, what are the objectives? Why it is done? Why it is necessary for the substation design? So one is your selectivity or discrimination. Selectivity or discrimination. Selectivity or discrimination. The ability to isolate only the faulty section while keeping the rest of the system energized. The ability to isolate only the faulty section of the network, electrical network, part of the or section of the electrical network of the power system is isolated due to fault, and this isolation should take place very speedily, as soon as possible. The fault must be cleared as rapidly as possible to prevent the equipment damage and maintain the stability. Third point is the system must always operate when required dependability. The system must always operate when and refrain from operating for external faults. So the system must always operate when required. Then next point is your sensitivity. The relays must detect even the minimum fault conditions within their protected zone. The minimum fault must be sensed by the protective relay. Last one is your zones of protection. The system is divided into overlapping segments, so no part is left unprotected. All the parts of the electrical power system is divided into different parts, different segments. For example, for transformer area, transformer zone, then bus bar zone. So is the zone protection. Then what is the primary methods of coordination? There are essential methods of coordination. One is your time grading, another is your current grading, and third one is your combination of time and current grading. That is the practical method. First, in time grading, we assigning the different time delays to the relays in the series. Suppose the relays are in series, relays are in series. So they are assigned time delays. There is a time gap between the downstream relay to upstream relay gradually. So that means closest to the fault. That means the relay farthest from the source, closest to the fault. Closest to the fault has the shortest delay. So it has been with the fault occurs here. So first it will sense immediately shortest delay. Then successive relays will be operated with a specified time delay. So while upstream relays are progressively delayed, limitation of this type of grading is slow fault clearing for upstream faults. For upstream faults, so for slow fault clearing for upstream faults. So when the fault occurs at upstream, then it is the fault clearing becomes slowest. So, but as per principle, it will be speedy. Why it will be speedy? To protect the equipments as soon as possible. Then current grading. The current grading is the setting relays to trip at the specific current levels. So the relay should sense a trip at the specific current. Upstream relays have higher pickup settings than the downstream ones. So the relays at the upstream having a higher pickup setting, so that it can operate at a higher current than the relay at downstream. Limited use for fault level variation. So due to fault level variation, it has the limited use. Use is the very rare. Third type of grading is your combination of time and current grading. This is the practical method, and this method uses both current setting and time delays to achieve the correct and efficient discrimination. So in this method, both current setting and time delays are taken into consideration to achieve the correct and efficient discrimination. It uses inverse definite minimum time relays. So it uses inverse definite minimum time relays. IDMT. That is called IDMT relays. So there are additional methods of protection coordination. One is your unit. The last three was main primary protection coordination, but here the additional methods of protection coordination. First is your unit protection. Unit protection is used as differential protection, comparing the currents entering and leaving the specific zone like a transformer. If they don't match the relay trips the instantly. Suppose there is a relay, there is which sends the input current and output current. So if there is a variation in input and output current as abnormally, then this will sense and the differential protection will be active. And this is fastest and most selective method of protection. Then the another protection is your distance protection coordination. It uses multi-zone, time graded settings. Typically 3 zones are there based on the measured impedance to ensure selective, fast and reliable fault clearance on transmission line. So distance protection relays are operated. Then adaptive protection coordination. It is a modern method where the relay setting is automatically updated to match the changing system. This is called adaptive protective coordination. So the key components of the substation protection. What are the key components? The key components of substation protection is one is your protective relays. It detects the abnormal conditions. For example, 50, 51 overcurrent, 87 is a differential, and the signals the breaker. They detects the abnormal conditions and signals the breaker. Accordingly, they signals the breaker to trip. It physically interrupts fault currents. What is the role of the circuit breaker during the protection? It physically interrupts or isolates the fault current. Then instrument transformer. It has also the role in protection coordination. It steps down the high current and voltages to safe levels for release to measure. So it must that means the ratio, the CTBT ratios, transformation ratios should be properly selected so that they will give proper output to the output currents will get for measurement as well as for the relays to operate. The other thing is DC power supply. DC power supply in the power system ensures that the protection system will work even during a total AC power failure through the battery banks. So DC power supply, suppose when the AC power fails, the DC power feeds to the protective system to operate. Here illustration of some protective scheme of a substation at 3x11 you see here. Engine cover, isolator, circuit breaker here. Core 1.5 for metering, 5P20 protective, CTPT. Here the CT ratio is 400/1. You see. It is for differential protection. PS class of city is used. So for feeder protection here, these are for feeder protection. 33 kV open circuit hard fault relay and transformer differential relay. Relay can be feeder relay, earth fault relays. 11 kV overcurrent earth fault relays. So this is the scheme of protection scheme for 33 by 11 kV substation. You observe and study this. Different digital relays are available nowadays. One is this is a overcurrent relay, differential relay. This is the resistance relay. This is under voltage, over voltage relay, frequency relay, reverse power relay, thermal relay, pilot wire relay, earth fault relay, phase sequence relay, R plus relay. These are various types of relays. So these are all about the protective relays and their details regarding the coordination, how they operate it. The rest of the topic we'll cover in the next class. Thank you.